Hi everyone. Today we'll do a problem from the topic Gauss Law in electrostatics, which is in class 12. The question says, let a total charge 2q be distributed in a sphere of radius capital R with the charge density given by rho equals kr, where r is the distance from the center. They should mention that k is a constant. This means the charge on the sphere is not uniformly distributed. It is non-uniform because as you move away from the center, small r will increase, and according to question, the density of charge will also increase because rho is given proportional to small r, right? Because small r is in the numerator, right? Two charges A and B of minus q each are placed on diametrically opposite points at equal distance small a from the center. If capital A and capital B, meaning the two charges, do not experience any force, then we need to find relation between small a and capital R. So this diagram explains the question. Here is the spherical charge whose density is given as k times small r. R is the distance from center. And A and B are 2 point charges minus q separated by distance of 2a. Now what they want is relation between r and small r so that one of these charge will not experience any force. Now why will this charge or this charge not experience force? The only way possible is this charge will exert repulsive force on this. This charge will exert on this a repulsive force. Then there must be another force in this direction. Then only the total force on this will be zero, right? Who will create this force? That has to be due to this spherical charge. And we know this spherical charge will create electric field inside and outside. So since we are not interested outside, what we have to first do is calculate electric field due to this charge at this point. Once you know the electric field at a point, the force on any charge at that point is given by F equals Q naught E, right? So what I need to do is find electric field at this point first. Now, in order to do problems faster in exam, it is important, students, that you remember some common results. For example, whenever you have radially outwards electric field produced by some spherical charge, then when you apply Gauss law, this result you need to try to remember. So how do we get this result? Well, we construct a Gaussian surface, which is a spherical closed surface of some radius small r. Then we apply Gauss law. What does Gauss law say? The flux through this surface is charge inside the surface, remember, inside the surface, divided by epsilon naught. Then the formula for flux is integral E dA cos theta. Theta here is angle between electric field and area vector. An area vector is drawn perpendicular to the surface, right? So at every point you can see area vector and electric field vector are in same direction. So for theta we can write 0. Cos 0 is 1. Also, because of spherical symmetry, all these points I can assume will have electric field which will be same in magnitude. So magnitude wise at every point E can be taken constant. Only magnitude, direction is obviously changing, right? As you can see, direction at different points are different. But magnitude can be taken to be same as long as we take a sphere. So once we know E is constant, we can take it out. Integral of this small area will give you total area of this sphere, and total area of this sphere is 4 pi r square. So whenever you apply Gauss law to a spherical surface which has radially outwards electric field, then remember this result. Electric field times area of the sphere is equal to charge inside by epsilon naught. Now the next thing we need to learn is how to find charge of a solid sphere. By solid sphere, what do I mean? There is charge inside also. Okay, so it's a solid sphere of charge, not hollow sphere where charge is only on the surface. So we have charge everywhere, and please understand it's a three-dimensional object. In the board it will look like circle, so please give importance to remember that this is a sphere. Now students, how to find charge of this? Well, one way is, think of onion. An onion is made up of shells, right? You start with a small shell and then you increase the radius of the shell and then finally you get a solid onion, right? Similarly, think of this spherical charge as made up of shells of charge, shells, okay? So here I have shown you one shell whose radius I have taken small r, and the thickness of the shell I have taken dr. So what would be the charge on this small shell? Let me call the charge as dq. Why dq? Because remember, this shell is just a part of the solid sphere. It is not the whole sphere, right? This shell here is just a part. So since it will have a small charge, I am writing it as dq. Now, how to write charge of this small shell? Well, the charge of this shell will be dq equals the density of charge at this location. So, at this location, whatever is the density times the volume of the shell. So, dv here represents volume of this shell, okay, only this part. Now, how do I write volume of this shell, which is dv? How do I write it in terms of radius? Well, let me show that volume separately here. So remember, I want only this volume, right? Now, think carefully. This is nothing but change in the volume from here to here, right? So if I consider this sphere, then this will be the volume. And if I consider this sphere, this will be the volume, the entire region. So if I subtract this volume from this inside volume, I will get this volume. So this is basically a small change in the volume, and that's why we are writing dV. Now, what was the original volume of this small region whose radius I have taken small r, right? So volume of that will be 4 by 3 pi r cube. And since we know differentiation, if you take differentiation of v with respect to r, 4 by 3 pi will come outside. Differentiation of r cube will give you 3r square. 3 will cancel. So if you cross multiply, the small change in the volume will be 4 pi r square dr. So the charge of this shell can be written as density into dV, where dV represents volume of this shell, remember, only this volume, right? Once I know how to find dq in terms of r, to find the total charge of the sphere, I just have to integrate. Matlab, I have to just add dq. So integrate rho into 4 pi r square dr. From where to where? Well, that depends from, if you want total charge of the sphere, let's say, then you have to increase the radius from 0 up to capital R, isn't it? So small r radius will go from 0 to capital R if you want the total charge of the sphere. So if you want charge only in half of the sphere, then you integrate from 0 to r by 2. What if I want only charge, let's say, in this part? Let's say this is r by 2. Then I have to increase my small r from r by 2 up to capital R. So depending on which region charge you want, you have to put the limits. Now, if your density is constant, then you can take it out. So only if density is constant. So if your density is constant, you can take density outside. So your charge will be, once density comes outside, what will you get? Rho will come out. 4 pi is also constant, and integral of r square dr is r cube by 3. When you put upper limit and then minus lower limit, you will get r cube by 3, which is actually, if you see properly, this formula says the total charge is density into total volume. But remember, this can be only done if density is constant. If density is not constant, then this way we have to do. So whenever they give you density of a spherical charge and they ask you to find the charge, what you must do is first find small charge dq on a shell, which is density of the charge at that location into volume of that shell, which is 4 pi r square dr. Because this is charge density, so this is charge per unit volume. When you multiply with volume, you will get charge in that volume. Once you have done that, then you have to integrate. From where to where you have to integrate depends on which region charge you want, right? Now coming back to the original question, remember they told the force on this minus q or this minus q. I have chosen this one. So the force on this minus q should be 0. For that, I need to find electric field here due to this sphere of charge, right? So let's do that first. So imagine this is the sphere of charge. Everywhere there is charge. It's not uniform, remember, because the density is a function of r. So at this point, how do I find electric field? Well, as you remember, I told you we have to construct a Gaussian surface. So this is my spherical Gaussian surface, and then you have to apply Gauss law. And what was the shortcut to apply Gauss law? E into area. What is area of this sphere? 4 pi a square, remember. Why a square? Because this radius is a. That should be equal to charge inside by epsilon naught, isn't it? Next, we need to find this charge inside. And charge inside can be written as integral density at this location rho into 4 pi r square dr. Now I have to integrate from where? Well, I want charge, remember, in this region. Only the charge inside the Gaussian surface should be included. So my radius should increase from 0 to a. So from 0 to a. Now what density they have given? Kr, substitute here. So this is Kr. Constants you can take outside. 4 pi k will come outside. Integral here r square. So integral r cube dr will give you r power 4 by 4. When you put the upper limit, you will get a power 4 by 4. So the 4 will cancel. So what is the charge inside we found? Pi k a power 4. And here you can see 1 pi will cancel. So here a square and a power 4 will also cancel. So finally, what is the electric field we found at this point? K a square by 4 epsilon naught. So this can be found very easily provided you know the shortcut of how to write Gauss law if electric field is radially outwards, which happens for spherical charge, and how to find charge inside a spherical Gaussian surface, right? Now having found the electric field at this point, now we can find the force on this minus q by this sphere, right? So if I draw this minus q at B at this point, then the force on minus q by this positive charge will be where? Well, you know electric field due to this positive charge is radially outwards. So electric field is outwards at this point, right? Radially outwards. But this is minus q. And we know negative charge feels force in what direction? Opposite to electric field. So since electric field is here, force on minus q will be here. In magnitude, how much it will be? Q into E. So this is the magnitude of the force on minus q by the spherical charge. Then who else will apply force on minus q? This minus q. And both are minus q, so there will be a repulsive force. And how will you write the magnitude of that force? Well, these two are point charges, so we can use Coulomb's law. 1 by 4 pi epsilon naught. Magnitude of minus q divided by distance between them is 2a. So 2a square will give you 4a square. Now since they told this minus q should feel no force, what does it mean? These two forces should balance. So q into E, and E is k a square by 4 epsilon naught, should be balanced by 1 by 4 pi epsilon naught q square by 4a square. So at least you can cancel this 4 and 1 q. So up to this we have reached. Now if you see the options, capital Q is not there. They want relation between A and capital R, right? So we need to find Q in terms of capital R. Now how to find Q in terms of capital R? Remember the total charge of the sphere was given 2Q. And how we can write total charge? Well, first find charge on the shell, which was density into volume of the shell, right? And then you have to integrate from here up to here, remember, right? Because you want total charge. So from 0 to capital R was given the radius. So 0 to capital R. So that is how you can find relation between Q and capital R. What was density given? K times R. So take constants outside. K and 4 pi are constants. Then integral r square r cube dr will be r power 4 by 4. Put upper limit r power 4 by 4. So this 4 can be cancelled. So 2q will be this, which means q will be k pi r power 4 divided by 2. These 2 I cross multiplied here. So now this q, you can cancel the 4. This q you have to substitute here. So if you do that here, what will you get? K a square by epsilon naught. Capital Q is K pi r power 4 by 2. And in the denominator we have pi epsilon naught 4a square. This k will cancel, this pi and this pi will cancel, epsilon naught and epsilon naught will cancel. So if you cross multiply, a power 4 into 2 times 4 is 8 equals to r power 4. So if you take r equals to power 1 by 4 you take. So here is r power 4 power 1 by 4. So this will be r. Here a power 4 power 1 by 4 will be a, and this will be 8 power 1 by 4. And then you can write small a equals to r divided by 8 power 1 by 4. When you take this up, it will be 8 power minus 1 by 4 into r. So the correct option is option A.